Hello everyone, in this video let's discuss about logistic regression. So logistic regression technique is used in supervised ML, which means uh, we have data for which we have x and the target variable y, and we train this model on this data so that while testing, if we get some input x dash, we need to predict output y dash. So that is the supervised ML setting in which logistic regression is used. So that too in classification problem. That means this y is, it belongs to a set of fixed values, like it could be like dog versus cat, or disease positive versus negative, like that. So this logistic regression is generally used in binary classification. So one generic doubt that we get is, this is used in classification, then why is this technique named as logistic regression? So regression is another machine learning technique wherein we try to predict a continuous variable y given an input x. So we know the linear regression equation, that is y equal to wx plus b. So in linear regression, what we are trying to predict is this target y given some x, and for given x the y is continuous variable and it can vary from plus infinity to minus infinity. But in classification, what we want is, we want the y value to belong to a fixed set of values. We don't need it to be continuous. So is there a way in which we can translate this problem setting into this binary classification setting? For that, there is a function in mathematics called logistic function or sigmoid function, which can come to our rescue, and then we can translate the range of y from minus infinity to plus infinity to 0 to 1. So essentially we are translating the target variable domain from minus infinity to plus infinity to this range in the probability of 0 to 1. Then if we can put some threshold th such that if the target y is less than this threshold, then we can classify it as that the target y as like class A, or if the y value is more than threshold, we could say like class B. So this is the basic essence of the logistic regression. So now we'll first understand what is this logistic function. So in the logistic function is nothing but let's call it like sigma of z would be equal to 1 by 1 plus e power minus z. So what is the specialty of this function? That this is helping us to translate the target variable range from minus infinity to plus infinity and bring it down to 0 to 1. So the thing is, if we see, if we put z as plus infinity, then sigma of plus infinity would become 1 by 1 plus e power minus infinity, that would be 1 by 1 plus 0, so it would become 1. And if z goes to minus infinity, then sigma of minus infinity would be 1 by 1 plus e power infinity, that would be 0. So we can see that the value of sigma of z only changes from 0 to 1, even though the actual z value is changing from minus infinity to plus infinity. And if z is equal to 0, then sigma of z will be 1 by 1 plus e power 0, that would be 1 by 2. So if we see the graph of the sigmoid function, basically it would be like this. So this is the z variable ranging from minus infinity to plus infinity, and we have seen that at z equal to 0 the value of sigmoid function is 0.5, and when z is plus infinity it has gone to plus 1, and minus infinity it has gone to 0. So the function graph would look like this. So it would asymptotically reach 1 at plus infinity and reach 0 at minus infinity. Now the y value, so this is the y value. The y value is also ranging from 0 to 1. So if we just replace z with, if we just put z equal to wx plus b, then we can just translate the linear regression thing into logistic regression by just applying a sigmoid on top of that, on top of this wx plus b. So the logistic regression actual function would be like probability of y or target is equal to 1 given x would be 1 by 1 plus e power minus wx plus b. So you see the regression part in the logistic regression is coming from this. We just applied a sigmoid on top of the regression, converted the range of the y to 0 or 1. Now the threshold part comes, where to decide the actual class, the decision rule would be like this. So the predicted y would be 1 or 0. It would be 1 if probability of y equal to 1 given x is more than or equal to 0.5. Otherwise it would be 0. So is it always fixed that the threshold should be 0.5? So that's not the case. So it could also be different. So that depends on problem to problem. And in order to identify how we fix the threshold, we'll see in the next class. Thank you.